Hello, everyone. I'm Mike, and my work revolves around the interaction between farmlands and the nearby streams and rivers. More specifically, all the paths that the water nutrients can take from the soil to the stream. So to grow crops in the amounts that we'd like, we need to apply nutrients to the soil, usually in the form of fertilizer. And since the farmers would like to grow as much as possible, they put a decent amount of fertilizer on the soil. Fortunately, most of this is taken up by the crops, but some are not. So when rain falls on some soil, it picks up some things along the way, some of which is also that fertilizer. And that the water and the nutrients will travel wherever the water may go. It may only go millimeters, it may go kilometers. And that's all dependent upon what paths that the water may take when it goes into soil. And so I have something to illustrate those kind of pathways. I've got some water with some coloring in it so that you can see the water better. I've got some sponges, and these sponges will represent the soil. The thin sponge will represent the topsoil where the crops grow, and the thicker sponge is all the soil below it. And if water passes from the sponge to the bucket, it's like the water and the nutrients passing from the soil to the stream. And so the first pathway we'd want to look at is kind of the more obvious one, and usually the one that people think of more dominant. So if you use an old sponge on top here, one that's not so good anymore, you pour some water in it, and it flows directly into the bucket. So the water would be flowing directly over the soil, directly into the stream, because this is an old, bad sponge. As I said, that may seem like the most obvious path that the water could take, just primarily because we can see it. We can actually go outside and we can see this happen. But actually, that's not the most common way it occurs, because like a good sponge, the soil has holes in it, and the soil can take up some of that water. So, which leads me to the next pathway. If we use a decent sponge, I hope this works, and we pour some water on it, it goes into the sponge. No water went out into the bucket. And imagine that amount that I put on was a small rainfall event. A little bit of rain, this sponge, just like the soil, will be able to soak it up to a certain degree. But if we have more rain, a lot more rain events, eventually it leaks into the bucket. Ooh, and some not in the bucket. Okay. So, but that usually takes quite a bit of time. As you saw, even with this, I had to pour a decent amount of water on top of the sponge before it really slowly started to come out. Soil, just like the sponge, can soak up a lot of water. The third primary way, let's use this, is that it's kind of a combination of the last two. There's a lot of little animals and critters in the soil, like mice and moles and earthworms and a lot of other things that make tunnels in the soil. A lot of tunnels, little tiny pipes. And just like any pipes, they can move the water pretty efficiently through the soil. And they usually like to burrow just under the topsoil. So if we just layer some of these, we have the good topsoil, which the water can pass through, and then we have the bad sponge. And you can see that it should hopefully flow out much easier and quicker than the second pathway that we saw before. It doesn't take a large rain event for the water to flow through these little tunnels and pass into the stream, or in this case, the bucket. So that may seem a bit complicated all the combinations of these things. But it gets actually even more complicated than that, unfortunately, because with all those pathways are also dependent upon a lot of different conditions outside. Like, for example, the types of soil, the type of climate, the amount of rainfall, the intensity of the rainfall. Harder rain will have different effects on it. So that's essentially what I'm doing. Since too much nutrients passing from the soil to the stream is bad for the environment, bad for the rivers and things like that, I'm looking into what pathways and processes are more dominant in transferring all this water and nutrients to the stream during different parts of the year so that we can ultimately reduce that to be able to improve the water quality of the rivers themselves. Thank you.